You know, what does your heartbeat actually have in common with an electrical circuit? I know, it sounds a little weird, right? But today, we're diving into the hidden math behind our most vital organ. And it turns out, the very rhythm of our lives can be decoded with one single powerful formula.
So, that's the big question we're tackling in this explainer. How on earth can a simple math formula capture all the complexity of the human heart? Well, let's jump right in and find out.
To get started, we've got to translate biology into a language that math can understand. We're going to use a really cool field called mathematical biology, where we build models to simulate and even predict how these incredibly complex biological systems actually work.
But first things first, let's take a quick tour of the biological pump we're trying to model. The heart, as you know, is this powerhouse muscle, and its whole job is to pump oxygen-rich blood to literally every part of your body. So how does it do it?
Well, it's all thanks to this brilliant four-chamber system. Let's follow the blood's journey. First, all the deoxygenated blood comes back from your body and flows into the right atrium. From there, the right ventricle gives it a big push, sending it to the lungs for a fresh tank of oxygen. Then, that newly oxygenated blood comes back into the left atrium, and finally, the powerhouse left ventricle pumps it out to the rest of the body. It's this perfect, non-stop loop.
So how do we turn all of that incredible biology into a simple mathematical model? This is where it gets really interesting. We use an analogy. We're going to imagine the entire cardiovascular system as a basic electrical circuit.
And what's wild is how well this works. The parallels are they're incredibly direct. The pressure difference that pushes your blood, that's just like voltage in a circuit. The actual flow of your blood, well, that's the current. And even the physical properties of your blood vessels have direct electrical counterparts.
So, the first key property is resistance. Think about it like this. Just like a really thin wire resists the flow of electricity, your blood vessels create friction that kind of pushes back against the flow of blood. This is a huge factor in figuring out how hard your heart actually has to work.
The second property is something called compliance. This is basically how stretchy your blood vessels are. See, when your heart pumps, the vessels expand a little, and they store some of that energy, exactly like how a capacitor in a circuit stores an electrical charge. Then, in between beats, they shrink back, releasing that energy to keep the blood moving smoothly. This is the secret to turning a pulsing heartbeat into continuous blood flow.
Okay, so by translating biology into these circuit parts, we can finally stop just describing the system and start, well, calculating it. And it all boils down to one single, incredibly powerful equation.
It's a principle from fluid dynamics called Poiseuille's law. And what this law shows is, honestly, it's stunning. The amount of blood that can flow through a vessel isn't just tied to its radius, or even its radius squared. It's proportional to the radius raised to the fourth power.
Let that sink in for a second. That number, 4. This isn't a simple straight-line relationship. It's exponential. And this one little number is the mathematical key to understanding just how fragile our cardiovascular system can sometimes be.
So now, let's see how this abstract math concept becomes a life-or-death reality. Because that power of 4 is exactly why even a tiny blockage in our arteries can have absolutely devastating consequences.
Here's what that exponential relationship looks like in the real world. A tiny 10% narrowing in an artery, something you'd probably never even feel, slashes your blood flow by over a third. A 25% narrowing, that wipes out a staggering 70% of the flow. And if an artery is blocked by 50%, you'd think flow would be cut in half, right? Wrong. It causes a 94% reduction. The vessel becomes almost completely useless. It's just incredible.
And that brings us right back to where we started. As the researchers whose work inspired this explainer put it, these mathematical models aren't just an academic exercise. They give us truly valuable insights into the dynamics of the heart, helping us understand health and disease in a way that just biology on its own really can't.
So, a simple rule from physics, looked at through the lens of mathematics, reveals a deep, fundamental truth about our own bodies. It just goes to show you that even our most complex biology can sometimes be understood through simple, elegant formulas, which really just leaves us with one final question to think about. If math can decode the heart, what human mystery will it solve next?